Today we are going to cover section 7.2, multivariable linear systems. So take the time to copy your title and your essential question. How do you solve systems of linear equations in more than two variables? Copy example number 1, and we'll start once you're ready. Go and pause it. So in elementary, you guys learned to graph a one-dimensional point. When we have x equal to 1, we form a number line. We place 0 in the middle. Then we know that this is your x-axis, positive on the right, negative on the left. And positive 1 is here. And we place a point. Now in 7th grade, you guys covered your x and y, so points in two-dimensional. And let's go and make a 5x5 graph to be able to plot it. So I'll make 2, 4, 5, 2, 4, 5. Where once again we have your x-axis, but now we added a y-axis. We know to the right is positive, to the left is negative, up is positive, down is negative, and to plot it we just 1 and up 2. So 1 to the right towards the x, and up 2 towards the y. Now we are introduced to x, y, and z, and you actually covered this last year, correct? So this should be mostly all review, and I assume that you graphed it as well. So let's go and make a axis. So I'm gonna make a vertical axis 2, 4, 5, 2, 4, 5. I'm gonna make a horizontal axis. But now we have where we used to have your x and y axis. What we're going to do, we're going to introduce a new axis, which will be your z-axis. So now we have, before it used to be like this. Once we introduce your z-axis, it's actually the formal way of writing it down, or the standard way is to be able to write it down as this, where your x and y will be the flat one horizontally. So therefore, this will be your y-axis, and your x-axis is the one that's coming towards you. So we're going to I'll make it into a diagonal. Makes it a little easier. This will be your x-axis. So if you see it as a three-dimensional, where that is your flat one going something like this. Have it backwards. So something like this, correct? And your z is up and down. Where your x is positive towards you, that'll be positive. Negative going back, positive towards the right on your y, negative to the left. Z, positive, up, down, down, negative. And now we're going to plot the point. So 1, positive towards x, so therefore I'll go 1 unit towards the right, or towards you. Then 2, positive, 1, 2 on the y-axis. And then up 3, 1, 2, 3. And that will be your point. And you can kind of see it floating above, which is difficult to see in a two-dimensional paper, correct? So therefore, we're going to go into Desmos, and I'm going to click on Start the Calculator, Graphing Calculator. And if I go into Desmos and I type in the point, which is 1, 2, but once I introduce a z value, it's not able to graph it for us. So therefore, we cannot use Desmos. Desmos doesn't allow you to graph in three-dimensional plane. So instead, we're going to go into an older system called GeoGebra. And some of you guys might have used it for geometry. So GeoGebra.org, it has a 3D calculator. So I'm going to go into the 3D calculator. And once I click in here, is going to give me a three-dimensional plane or three axes, your x, your y, and your z. And I do prefer to get rid of the keyboard, so just like I have it here. And now notice that in this case they have the x and y axis is grayed out. So which is your x-axis? And sometimes the orientation might be slightly different. You can actually change it by rotating it. So let's say if I type in 1 comma 0 comma 0, that is your x-axis. So where we're going to place your x-axis, we're going to place it like this. So it's on the same shape. Now notice that if I type in 0 comma 2 comma 0, that is your y-axis. Therefore your z, if I type in 0 comma 0 comma 3, that is your z. So that is the proper orientation that we have it, but you might orient it anywhere, any way you want. Now to be able to plot the point, let me get rid of this, delete, delete, and I'm just going to type in 1 comma 2 comma 3 and press enter, and now you can see the point flowing above, correct? So that is a three-dimensional point. So 1 towards your x, 2 towards your y, and up 3. So now let's go through example number 2, and now let's go and graph a plane. Go and copy it down, and we'll start once you're ready. Go and pause it. So now let's go and build your, once again, a 5x5, 2, 4, 5, 5x5x5. That is your z. This is your y. And now we're going to build your x. And actually just place as a diagonal to control u. That is your x. That is your y. And this is your z. And now we need to be able to graph this plane. So what we're going to do, we are going to find each of your intercepts. We're going to find your x-intercept. Now, do you remember how to find your x-intercept? Back from linear equations, to find your x-intercept, you let y equal to 0. But since this is a three-dimensional plane, we're also going to let z equal to 0. So therefore, that'll be 2x. But we're actually looking for the x. So it'll be 2x. Instead of the y, we're going to plug in a 0. Instead of the z, we're going to plug in a, so 2x plus 3y minus z equal to 6. So instead of the y, we plug in 0. And now we can solve for x. That cancels, so therefore 2x equal to 6, so therefore x equal to 3. So therefore the intersection will be a point, will be 3, 0, 0. So therefore it will be 1, 2, 3. That's where it crosses your x-axis. Now let's find the y-intercept. So find the y-intercept. Then find your z-intercept. And see what you get. Go and pause it. Correct. So to find the y-intercept, I'm going to let x equal to 0 and z equal to 0. To find the z-intercept, I'm going to let x equal to 0 and y equal to 0. So therefore, if I let x equal to 0 be 2 times x plus 3y minus z equal to 6. So it gives me 0, plug in 0. So therefore, 3y equal to 6. So therefore, y equal to 2. So therefore, it's going to cross the y-intercept at a point at 0, 2, 0. So therefore, which will be here. And now, to find your z-intercept, it'll be 2 times 0 plus 3 times 0 minus z equal to 6. So therefore that will be a 0, 0. So negative z equal to 6. So therefore z equal to negative 6. And remember that this is a point, your intersection. So your x is 0, your z is 0, and your y is 2. Same thing for here. That will be a point of intersection where your z is negative 6, your x is 0, and your y is 0. It'll be 1, 2, 3, 4, 5, and let me go down one more, 6. And we are going to connect all 3 points. Now it's really difficult to graph a plane by hand. So what we're going to do instead, we're just going to highlight that triangle. And we are going to assume, or we are going to know that that triangle kind of expands throughout the entire. It's not just a triangle, it's an entire plane, so it continues going this way and beyond. Now let's go ahead and graph it. I'm going to go and type in, get rid of this. I'll just go and click on the 3 dots, delete it. And I'm going to type in 2x plus 3y minus z equals 6. And that is the plane. Now, we can get rid of the gray x and y plane by clicking on the little toolbar, click on the plane, so it kind of disappears. And can you drag it up? I want to zoom out so we can see the intersection. So the way that we have it is something like this. Now we can also plot the points if we want to just kind of see the intersections. So the first point is 3, 0, 0. The next point will be 0, 2, 0. And the last one will be 0, 0, negative 6. And that way you can see that's where the crossing, you can see it right there. So that is a plane in 3-dimensional. 3 dimensions will be x, y, and z. Now let's go over to the next scala. Go and paste it and pause it, and we'll start once you're ready. So in this case, we have consistent systems and inconsistent. Do you remember the difference? Consistent is whenever there's at least one solution. There can be a single solution where they cross out a specific point, or if we have all those planes crossing at one line, then we have an infinite number of solutions. All those points on the line are solutions of all 3 planes. Or if we have 2 planes that are exactly the same, and then we have one more plane going through both of them, we still have an infinite number of solutions. Or in this case, all 3 planes are the same, then we also have an infinite number of solutions. So we can have one solution or infinite many solutions on those 3 cases. In consistent systems is when we have no points in common. And we have 4 cases as well. It can be that all 3 planes are stacked on top of each other, so there's no point of intersection. It can be that 2 planes are stacked on top of each other, and then there's one that crosses them. So there's no point out where all 3 of the planes cross. We can have it where there's a gap in between, or we can have it where there are 2 planes that are exactly the same, and the third one is stacked right below it or above it. So let's go through example number 3. Go ahead and copy it down, pause it, and we'll start once you're ready. Solve the system of equations, then check your solutions. So you covered this last year. Do you remember how to solve this type of systems? So go ahead and pause it, solve it, see what you get, and then we can compare our answers. And you can decide whether you want to do it by combination or substitution. So in this case, go and pause it. You got your solutions. So in this case, I notice that there's a z value already solved for, correct? So therefore, I'm going to take my z value and plug it back into the previous equation and find the value of y. So let's go and find y. To find y will be y plus 3. Instead of the z, I'm going to replace the value of z, which is 3. And now I can solve it, so it gives me y plus 9 equal to 6. So therefore, y is equal to negative 3. And now I'm going to take the value of z, the value of y, and I'm going to plug it back into the first equation so I can find the value of x. So let's go and find x. So therefore will be 2x, that's what I'm looking for, minus y, which is negative 3, plus 5z, which is 3. So therefore that is negative 3, that is 6. And now I can just solve for x. That is the only variable that's left. So therefore I have 2x plus 3 plus 30 equal to 22. 2x plus 33 is equal to, where did I get my 6? That should be a 3, right? Let me just fix that before I continue. You probably saw that before I did. So it'll be plus 15. That will give me plus 18 equal to 22. Therefore 2x equal to 4 and x equals to 2. So I found my solution. My solution is an intersection of all three planes. In this case is 2 comma negative 3 comma positive 3. Now I need to check my solution. Let's go and check it algebraically. To check is a very quick process. So you should be checking your answers on every single problem. You are only asked to check it on specific problems, but ideally you should check it every single time. So how can I check my solutions? I'm plugging the value of x, the value of y, and the value of z, and that should be a true statement for each of those three equations. So let's try the first one. 2x minus y plus 5z is equal to 22. The value of x is 2, the value of y is negative 3, and the value of z is positive 3. So 4 plus 3 plus 15 equal to 22. That's 7 and 15 is 22 equal to 22. Perfect. So that is correct. So try the second one and the third one and see what you get. Go and pause it. So therefore, let's check the second one. So we have y plus 3z equal to 6. The y is negative 3 and the z is positive 3. So it gives me negative 3 plus 9 is equal to 6. 6 equal to 6. Perfect. So the last one that we need to check is z equal to 3, where z is 3, and that one works. So therefore, we checked algebraically that is the solution. But we can also check graphically. So if I go back into GeoGebra, you should be doing this as well. Let me go and delete. No, we don't delete them all. So I'll type in my first equation, which is 2x minus y. I'll apply 5z equal to 22. My second equation, which is y plus 3z equal to 6. And notice that starts graphing them for me. And the last one will be z equal to 3. Can I change the color? If I go under settings, then I'm going to change the color, and you can select the color. Let's select the red one. That's good. Let me select this one to be settings. You can also click on the little settings, and let me change the color, and I will just change it to green. That's too close, so it's blue. Oh. There you go. So now you should be able to see your intersection. You can see it's right there. So I'm going to type in my solution on the next line, which is 2 comma negative 3 comma 3. And you can see if that is my solution, and it is. Correct? So now let's go to example number 4. solve the system of equations and check your solution. Go and pause it, see what you get, and then we can compare answers. Well, so now let's go through example number 4. Let's go and solve this system by combination. Go and write it down, pause it, and we can work it out together. So when we're solving systems of equations, you get to decide whether you want to do it by combination or by substitution. In this case, I'm going to do it by combination, and most of the time we do prefer by combination. I want to decide whether I want to cancel my x's, my y's, or the z's, and you get to decide. In this case, I'm going to cancel. Which one looks easier? My x's look easier to cancel, correct? And you're going to get 2 at a time. So I'm going to grab my first one and my last one, and I'm going to place my arrows here. If you have a red pen, it will be much easier, because that will tell you which ones you grab, and that will reduce the amount of writing that you have to do. So therefore, if I add them, the x's automatically cancel, so I don't need to multiply by anything. Now remember that we cover substitution on the last section. And now my x's are gone, and that's what we wanted to happen. So that we have y plus 3z is equal to 5. Now, since we cancel the x's once, we need to cancel the x's again. So therefore, you can select the first one and the third one, or the second one and the third one. Which one do you prefer? You want to cancel the x's again. So I'm going to select the second one and the last one. Do you agree? And I'm going to multiply this one by 2, because I want that to be a -2, so the x's cancel. Remember that I need to see the little number there. That way I can check, and it's also easier for you to be able to go back and double check in case you make any mistakes. So multiply by 2 gives me a -2x plus 6y, use some space for uz, minus 8. This last one stays the same. And now my x's cancel just like we wanted them to. So now I have y plus 5z is equal to 9. And now I have y's and z's. Remember, if you're going to cancel your x's, you want to cancel your x's again, so that way you end up with the same variables. If you end up with different variables, that is because you already made a mistake. So therefore, I'm going to place them one on top of the other. And you get to decide, do you want to cancel your y's or your z's? Correct, your y's probably. I'm going to multiply the top equation by -1. That gives me a -y minus 3z is equal to -5. Now your y's cancel out, so therefore I end up with 2z equal to 4, z is equal to 2. Now remember that once you combine those two, that was like a 2 by 2 systems of equations. Now, if I find the value of z, what should I do? Correct. I should plug into either one of those two to find y. And you get to decide, does it matter where I plug into the first or second one? No. So therefore, I'm going to plug into the first one, y plus 3z equal to 5. But instead of the z, I'm going to plug it in 2. So that gives me y plus 6 equal to 5, y equals -1. I have the value of z, the value of y. So now what should I find? Correct, I should find x. And you get to decide, do you want to plug into the first equation, the second one, or the third one? It doesn't matter. I might use the first equation. X minus 2y plus 3z is equal to 9. But instead of the y will be a -1, instead of the z will be a positive 2. And now we can just solve for x, since that is the only variable that we have. Positive 1, correct? So therefore, my solution is the intersection of all three planes, my solution, only one solution, are 1, -1, and 2. And I need to check my solution. So go and check it, see if we got the correct answer. Hopefully I did not make any mistakes. Sometimes the mistakes that you make will be just like a little sign that you left, or sometimes you forget to multiply the last number. So therefore this x, y, and z should make each of the equations true. So let's start with the first one. X minus 2y plus 3z equal to 9. 1, -1, and 2. 1 plus 2 plus 6 is equal to 9, so 9 is equal to 9. Checks. Second one, -x plus 3y equal to -4. So you have 1, -1. So that was -1 minus 3 equal to -4. -4 equal to -4. Check. And now the last one. 2x minus 5. If the last one's wrong, that means that it was on the first equation, it was on the first plane, on the second plane, but it was now on the third plane, and that is because you made a mistake above. So hopefully that's not the case. So your x is 1, your y is -1, your z is 2. So it's 2 plus 5 plus 10, that is equal to 17, correct. So now let's go and check your answers graphically. Just delete all three of them. Makes it a little easier for me to just retype them. X minus 2y plus 3z equal to 9. First plane, -s plus 3y equal to -4. And the last one is 2x minus 5y plus 5z equal to 17. And I forgot the z in there. Now let me go and change the things. So I just want the settings. There you go. I want it to be red. I'm gonna get green and yellow, orange, or blue. There you go. So now, can you see the point of intersection? It's hard to see, but it's right there, correct? So one way to find out if it's correct is by applying the point, which is 1, -1, and 2. And I'm going to zoom in. And you can see that right there that it does cross all three planes. So therefore, that is the correct solution. Let's continue to example number 5. I'm going to copy it down, pause it, and we'll start once you're ready. So take the time to solve the system by combination. See what your solution is. Go and pause it, and we can check your answer afterwards. Got it? So in this case, I'm going to choose to cancel the y's. And I'm going to select the first and second equation to cancel the y. So therefore, I have automatically they cancel, so I can just copy them down. X plus y plus z is equal to 6. 2x minus y plus z is equal to 3. My y's cancel out. I have 3x plus 2z equals 9. Since I canceled the y's the first time, I need to cancel the y's once again. So that way I end up with x and z on my second equation. So I'm going to select either my first one and the last one, or the second one and the last one. I'm going to select the second one and the third one. So therefore I have 2x minus y. Automatically they cancel out, so I don't need to multiply by anything. So therefore my y's cancel out, and I have 5x But in this case, my z's cancel out as well. So I end up with equal to 5. So from here I can solve x equals 1. And ideally, I should have been able to combine those two equations. So what should I do next? Correct, I can just plug in the 1 in here. So I can solve for z. So I'm going to find z. So it'll be 3x plus 2z is equal to 9. I'll plug in a 1 and solve for z. So it'll be 3 plus 2z equal to 9. 2z is equal to 6. Z is equal to 3. I have x, I have z, so I need to find y. To find y, I'm going to plug it into the first, second, or third equation. In this case, I'm going to plug it into the first equation. I actually select the one that has smaller numbers. So therefore, it'll be x, which is 1, plus y, which is what we're looking for. Z is 3, and that'll be equal to 6. So y plus 4 equal to 6, so therefore y equals 2. So therefore, my solution is the point of intersection of all three planes, which is 1, 2, and 3. And now I need to check my solution algebraically. So let's go and check it. Checking is a very quick process. So therefore, it'll be x plus y plus z is equal to 6, where x is 1, y is 2, I can choose 6 equal to 6, which is correct. Now let's check the second equation, which is 2x minus y plus z equal to 3. X is 1, 2, and 3. That gives me 2 minus 3 minus 2 plus 3. Gives me 3 equal to 3, and that checks. And the last one, let me see if I can fit it in here. Minus 1, 2, and 3. So it gives me 3 plus 2 minus 3 is equal to 2. Yes. And also, you want to be able to take the time to check them graphically. So I'm just going to delete all 3. Actually, or you can just retype them over them. So we x plus y plus z equal to 6. That's our first plane. Let me zoom out so we can see. Then my second one will be 2x minus y plus z equal to 3. And the last one will be 3x plus y minus z equal to 2. And if you notice, hard to see if it's the same color. So we just go under the settings. And now I should be able to see the intersection. Notice that is intersecting right there. So now I can see the intersection. I'm going to type in my solution, which is 1, 2, 3. And notice that that is the correct intersection. Perfect. So now let's continue to example number 6. So take the time to copy it down, and then we can work it out together. Go and pause it. So I need to be able to find the quadratic equation in this form, which is standard form, where I need to be able to find the value of a, b, and c to find the equation, whose graph passes through the points -1, 3, 1, 1, and 2, 6. So let's go into Desmos. So now we're going to go back into Desmos. And let's go and type in all 3 points. My first point is -1, 3. My second point is 1, 1. And my third point is 2, 6. You can also do the same thing on a graphing calculator. So notice that we have all 3 points. I want to be able to find a parabola that will go through all 3 points. If you remember, we did something similar on chapter 2, but they give you the vertex. So they gave you 2 points, and one of them was a vertex. In this case, there are 3 unknowns, and that's why we have 3 points. What we're going to do, we're going to get the first point, which is -1 comma 3. I'm not plugging the value of x and the value of y into the equation. So therefore, instead of the y, I'm going to replace it with a 3. Equals, instead of the x, I'm going to replace it with -1. So that is -1, that is -1. And now I'm going to simplify. I'm going to place the equal to 3 on the right hand side. So I'll be a, -1 squared is 1 times a gives me a, b times -1 is -b, and we have positive c, and that is equal to 3. And I'll be doing the same thing for each of the points. That will give me another equation, and that will give me another equation. So for 1, 1, the y value is 1, and the x value will be 1. One square is 1 times a is a. That gives me a b, c, and that will be equal to 1. Now let's do the same thing for the last one. C, for the last one, y is 6. We have a squared plus b plus c. Where now the x value is 2. 2 squared is 4 times a will be 4a plus 2b plus c will be equal to 6. And now we have 3 unknowns, a, b, c, so therefore we have 3 equations, so we can solve it. So solve it either by combination or by substitution and see what you get. Go ahead and pause it. So in this case, you should have solved it and got the values of a, b, and c, correct? So I'm going to go and cancel the b's. I'm going to get my first equation and the second equation, and the b's automatically cancel. So therefore I have a minus b plus c equals 3. A plus b plus c equals 1. My b is cancelled, so therefore I have 2a plus 2c equals 4. Now I cancel the b's. I want to cancel the b's again, so therefore I'm going to get the first one and the last one. And I want the b's to cancel, so therefore I'm going to multiply the first one by 2. That'll give me 2a minus 2b plus 2c equals 6. It gives me 4a plus 2b plus c equals 6. This cancels. That gives me 6a plus 3c equals to 12. Remember that one of the most common errors is this: you forget to multiply the last number. And now I'm going to combine both of those two equations, and I want to cancel the a's or the c's. Which one should I cancel? Correct, I should cancel the a. So I'm going to multiply this one by -3. Do you agree? So it gives me -6a minus 6c equal to -12. That is 6a plus 3c is equal to positive 12. So therefore my a's are cancelled. I have -3c is equal to 0. So therefore c equal to 0. Divided by -3. And now we have the value of c. What should I find next? I should find the value of a. And you get to decide whether you want to use this equation or that equation. I'm going to use this one instead. It'll be 2a plus 2, instead of the c is 0, equal to 4. 2a equal to 4, so therefore a equals 2. I have the value of c, I have the value of a. Now I'm looking for the value of b. So let's go and find b. You get to decide whether you want to plug into the first, the second one, or the third. I'm going to plug into the second one since it has smaller numbers, so therefore I have a is 2, b is what I'm looking for, c is 0, and that will be equal to 1. So therefore, b plus 2 equals 1, so therefore b equal to negative 1. Since I have the value a, b, and c, now I can plug into my equation. So my equation will be y equals a, well, the value of a is 2. So therefore, it will be 2x squared. The value of b is 1, so we minus 1x, and plus 0. But do I need a 0? No. So therefore, my answer will be y equals 2x squared minus x. And if we did it correctly, then when I graph the equation that we found, it crosses all 3 points, 1, 2, and 3. So therefore, that is correct. Now we can also check it algebraically. If I need to be able to check algebraically, we can just plug in the values, the points, x and y, x and y, x and y. So let's go and check it very quickly. I'm going to use the first point, negative 1, 3. So instead of the y will be 3. Instead of the x will be negative 1. So that gives me 3 equals, negative 1 squared is 1, times 2 is 2, plus 1 is 3 equal to 3. Perfect. I'm going to check the second point to make sure that that is correct. Y value is 1. The x value is 1 as well. So therefore 1 equals, this is 1 squared is 1, times 2 is 2, minus 1 is 1. And I just need to check the last point. Your y value is 6. Your x value is 2. So 6 equals, that is 4 times 2 is 8, minus 2 gives me 6. So checking your answers algebraically is just a very quick process that you kind of want to get used to, especially on the test. Example number 7. Go and copy it down, and we'll start once you are ready. So I need to be able to solve the following system. I need to decide whether I want to do it by combination or substitution. So notice that you're missing some x's and an x and a y. So what should we do? X's or cancel your x's or cancel your z's or your y's. Let's go and cancel my x's, correct? Because once I cancel the x's, I'm going to end up with y and z, and I can combine it with that equation here. So let's say, to cancel the x's, I don't need to multiply by anything. So let me just rewrite them. X plus y minus 3z equals negative 1. That gives me negative x plus 2y, leave some space, equal to positive 1. So now my x's are gone. And I have 3y minus 3z is equal to 0. Now I'm going to cancel the x's again. No, I can just get this equation here. So I'm just going to write down here. Y minus z equal to 0, correct? The x is gone there. So now I'm going to combine those two equations into one. And I have 3y minus 3z equal to 0. And I'll combine both of them. So I multiply this one by, do you want to cancel the y's or the z's? Well, actually, let me just take an extra step. Y minus z equal to 0. So therefore, I'm going to cancel the y's. I'm going to multiply by negative 3. So the first equation stays the same. Second one multiplied by negative 3. Negative and negative is positive. So therefore, your y's cancel, your z's cancel, so I end up with 0 equal to 0. Once I have 0 equal to 0, is that true or false? That is a true statement. So what does that mean? That means that we have an infinite number of solutions. So infinitely many solutions. And now notice that you'll be either this, where they all cross at a specific line, it might be this case, or it might be that case. And we need to be able to decide. So we have infinitely many solutions, but we do still need to be able to find the solutions. So we need to be able to either get this equation or this equation, and you want to be able to solve for y or for z. You get to choose. Now, your book, the way that they have it is that your solution will be a set of points. They are going to place the value of z, but you don't always have to solve for z. You usually select the one that's usually easier to solve for. So notice that in this case, it'll be easier to solve for y. So I'll move my z to the right, we can say. So I must solve for z, for y. So therefore, I have y minus z equal to 0. So for y, move the z to the right, we can say positive. So y equal to z. So therefore, we set up the value of z. And we know that the y value is also z. So therefore, we need to be able to find the x value, but we also want it in terms of z. So therefore, do you want to plug in the value of y, and the value of z into the first, second, or third equation? It doesn't matter. So let's go and select the first equation, correct? So let's go and find x. So it'll be x plus y. By instead of the y, we're going to replace it with a z. Minus 3. By instead of the z, we're going to replace it with a z equal to negative 1. Now, combine like terms. X minus 2z equal to negative 1. Solve for x, so therefore x equal to 2z minus 1. So instead of the x, we're going to replace it with 2z minus 1. And this is the value of x. Now, these are infinite number of solutions. So now you get to be able to find some solutions. Remember that we have infinitely many solutions. So we're going to let z equal to a number. You get to choose. What do you want to let z equal to? 0? Perfect. So therefore, will be 2. Instead of the z will be a 0 minus 1. Instead of the y will be a, instead of the z will be a 0. The x value is also, the z value is also z, so therefore will be 0. So that gives me negative 1, 0. 0 is one of the solutions, if we did it correctly. Now let z equal to, let's go and find 3 points. Let z equal to any number. We can choose 10, 20, 1,000. I must plug in a 1. So it'll be 2 times 1 minus 1. That's the value of x. The value of y is z, which is 1. The value of z is z, which is 1. So that gives me 2 minus 1 is 1, 1, 1 is another solution. I need one more. Let's go and, well, we can do 10 more if you guys want. But let's just do one more. Let z equal to 2. Perfect. So my first value will be, my x value will be 2z minus 1. So it'll be 2 times 2 minus 1. My z value will be, my y value will be z, which is 2. And my z value is 2. So it'll be 4 minus 1 will be 3, 2, 2. And those are 3 of the solutions. Now I can check algebraically if this is correct. How can I check to see if this is a correct solution? I can just plug into all 3. How can I check to see if this is the correct solution? I can plug into all 3. How can I check to see if this is a true solution? I can plug into all 3. But for now, let's just do it to save a little more time on our lesson. I want to go back into not decimals, but GeoGebra. I'm gonna leave this, yes, I can leave this space. And now we'll go to the 3D calculator once again. You can sign in, create an account. We'll be doing that some other time. Let me wait until it gives me the X, Y, and Z plane. And now I can just type in my first equation, which is X plus Y minus 3Z equal to -1. And I prefer to get rid of my shaded X and Y. So I'll click on the settings and get rid of the plane. My second equation will be Y minus Z equal to 0. And my last equation will be -X plus 2Y equals 1. And once again, let me go and change the colors. Red, we decided was a good one. Then green, and then bright blue. And now I should be able to see, notice that, do you see which case is it? Is it case 1, case 2, or case 3, or case 4? So it's this one here, correct? All the points are in one line. So therefore, and you can see the line there. So I'm gonna plug my first point, so hopefully that is correct. 1, 0, 0. And notice that that one falls on the intersection. My second point is 1, 1, 1. That one is also on the intersection, so far so good. And the last one is 3, 2, 2. And that one's also the intersection. And on the test, we'll be asked to be able to check algebraically one of the points to make sure that is correct. Example number 8. Go ahead and copy it down, pause it. So in this case, I need to be able to solve the following system. I need to be able to decide whether I want to solve it by combination or substitution. Combination, correct? And you want to cancel your x's, your y's, or your z's. Probably your x's. But let's do it together. At least I'll decide how we're going to approach this. Let's go and cancel the x's, and let's get the first one and the second one. And the first one I'm going to multiply by -2 to cancel my first x. And then I need to cancel the x's again. So I'm going to get the first one and the last one, and I'm going to multiply this one by -3. And I want to see that on your homework as well. Go ahead and pause it, solve it, see what you get, and then we can continue. Pause it. Excellent. So in this case, let's see, multiply by -2, so it gives me -2x minus 4y plus 14z is equal to +8. That one stays the same. So therefore my x's are gone, just like we wanted to. 15z is equal to 13. I'm going to cancel my x's again, so multiply by -3, so -3x minus 6y plus 21z is equal to 12. So I have y minus 15z is equal to -13. I'm going to go and combine them, and I want to cancel the y's automatically cancel, so it's perfect. -y plus 15z is equal to 13. Y minus 15z is equal to -13. My y's cancel, but then also my z's and also my numbers. So I end up with 0 equal to 0, which means an infinite number of solutions once again. So that is true. So we have infinitely many solutions. Now, there's going to be times that's going to give you a false statement, and then there'll be no solutions and you're done. But if you have an infinite number of solutions, now you need to be able to decide. And the equation to be able to get those solutions. So let's see, you want to be able to get one equation or the other. In this case, they're the same. So let's go and grab this equation. And you want to solve for one or the other, whichever is easier. Now in this case, I'm going to solve for y. So therefore, solve for y. I have y equals to 15z minus 13. So therefore, you're going to start with the z here. The y value will be in terms of z. So therefore, that'll be 15z minus 13. And now I need to find my value of x. But I want it in terms of z. So therefore, I'm going to take the first equation, the second one, the third one, and solve for x. Let's see, the value of x is what I'm looking for. The value of y is 2 times y, which is 15z minus 13 minus 7z equal to negative 4. I'm going to give myself more space. So x plus 30z minus 26 minus 7z equal to negative 4. Let's combine like terms. So it gives you x plus 23z minus 26 equal to negative 4. Move everything to the right, so x equal to negative 23z plus 22. Do you agree? I'll make, so that gives me negative 23z plus 22. That is the formula to find an infinite number of points. And now we get to find 3. So we're going to let z equal to any number you want. 0. Excellent choice. So therefore, that'll be negative 23 times 0 plus 22, 15 times 0 minus 13, and 0. So instead of z, I'm going to plug it in 0. That gives me 22 minus 13 and 0. Let me let z equal to, you get to choose 5, 2, 3, 1, perfect choice. So that'll be negative 23 z plus 22, comma, 15 times z minus 13, comma, 1. I'm going to plug in 1. That gives me negative 23 plus 22 is negative 1. This gives me positive 2 and 1. And I need one more, so let's go and let z equal to 2. Perfect choice. Negative 23 times 2 plus 22. 15 times 2 minus 13 and 2. So I'll plug in a 2 into each one. And I'll write it here. Negative 46 plus 22 is negative 24. Negative 30 minus 13 is, or no, positive 30 minus 13 is positive 17, and that gives me 2. So now let's check it. We can check it algebraically or we can check it graphically. And now in this case, let me just go back and change my equations. There are 2x plus 3 plus 5. So notice that there is a point of intersection, and we can see, is there a point of intersection? Yes. a point. So let's see. Did I mistype it? 3x plus 2z. Yes, I've got the z in there. There you go. So now we know that the point of intersection is a line, just like the previous one. So now let's go and see if those points are correct. 22, negative 13, and 0. I'll zoom out in a second and see if that's correct. The second one is negative 1, 2, and 1. And the last one, negative 24, 17, and 2. So we know that that one is correct. Let me zoom out. Zoom out a little more. There you go. So now we can see that all 3 points are in solutions for all 3 planes. And that is correct. Here with the last example for today. Go and copy or paste the word problem, and we'll start once you are ready. Go and pause it. Now take the time to read through the problem. We did one that was very similar on 7.1, and see if you can set up your 3 equations. Go and pause it. So at this point you have your 3 equations set up. So to expand its clothing line, a small corporation borrows $775,000 from 3 different lenders. The money was 8% from the first lender, 9% from the second one, and 10% simple interest from the third one. How much was borrowed at each rate when the annual interest owed was total of $6,705, and the amount borrowed at 8% was 4 times the amount borrowed at 10%. So let's go and set up our 3 variables. X will be the amount, the money borrowed for the 8% lender. Then we have Y will be the money at 9% from the 9% lender, and Z will be the money for the 10% lender. So that'll be the amount of money for each one. We know that in total they borrow, so therefore we have X plus Y plus Z should be 775. We also know that the interest that was charged in total was 67,500. So therefore, I'm going to convert this to a decimal. The interest for the 8% lender will be 0.08 times the amount that they borrowed. Same thing for the Y will be 0.09Y, and same thing for the Z. And that'll be a total of 67,500. Now the last equation, the amount borrowed at 8% was 4 times the amount borrowed at 10%. So 8% is the X. It's going to be the Z. So therefore, which one gives the 4? The amount borrowed at 8% was 4 times the amount borrowed at 10%. So the Z gets the 4, because if they borrow 10,000 for the Z, that'll be 4 times 10,000, that'll be 40,000. 4 times for the 8%. And now that we have our 3 equations, now we can solve. So let's see. Do you want to do it by combination or substitution? Well, first let's get rid of the decimals, correct? So let's go and rewrite it. So my first equation will be X plus Y plus Z equal to 775. Let's multiply by 10, so it'll be 8x, or by 100, plus 9y plus 10z and 67512 and then multiply by 100. Let me move the z to the left, so therefore I have x minus 4z is equal to 0. And now you need to decide whether you want to do it by combination or substitution. Probably want to do it by combination, correct? I have my x and my z, so I'm just going to get those two equations and I'm going to multiply by -9. So that gives me -9x minus 9y minus 9z. And I'm going to use, in this case, my calculator to multiply it out. So that'll be 775 and 3 zeros times 9. So that gives me 6975 and 3 zeros. And that'll be negative. The second equation will stay exactly the same. And now my y's cancel just like we wanted them to. I have a negative x plus z is equal to, I have that number there, so let's just multiply by -1. And I'm going to add 675 0 and 1 2 3, so I have a total of 4 zeros. So therefore that gives me -225,123. And now I'm going to get my other equation, and notice that they both have a x and a z, so now I can combine them, and automatically my x's will cancel. Let me just bring this one down over here to make it a little easier. So I have negative x plus z is equal to -225,123. And now I can solve for z. That'll be -3z is equal to, so now I can divide it by 3. By -3, so it'll be positive. So that is how much they borrow from the third lender at 10%. Now let's go and find out how much they borrow from the, let's go and find the value of x. So therefore x equals 4 times the amount that they borrow at 10%, which is $75,000. So it's a very quick process. I think sometimes the setup is the one that some of you guys might struggle with. So therefore x equal to 3, 1, 2, 3, 4, 5. $300,000 from the third one, and we know that all three of them together will be 75,000. So let's go and find a y. I'm going to use my first equation, which is x is 300,000, y is what I'm looking for, and z will be 75,000. And the total amount that they borrow is 775,000. So therefore y is equal to $400,000. So let's just go and list it. They borrow 300,000 at 8% interest, simple interest. Then we have 400,000 at 9% interest rate. And the last one is 75,000 at 10%. So this will conclude the lesson for today. Have a great day, and I'll see you guys next time.